first homework help video for Chapter 5 for statistics. The subject here is discrete probability distributions. I sincerely hope that you either read the book or look at the lecture notes. The lecture notes published for this chapter on Blackboard are short and hopefully very to the point and very compact, so there's not a lot to read. Up till now, you probably could have gotten by in this class just by using intuition and some previous experience, such as playing cards or something like that. But now, it's not that this is difficult, it's that what is going to be done for the rest of the chapter has to do with very specific definitions of charts and graphs and values that are being computed. And it might be things that you've never seen before. Again, not that they're difficult, it's just that they're very specific to statistics. The first problem in this homework set just has you graph a discrete probability distribution. I'm going to go through this one using girls, but boys is on the homework. I think you can figure that out. The whole idea here is how to create these graphs. In the past, I'm just going to write this little graph up here. We had a graph like this. We would put some values for the variable, and because these are discrete variables, they would just have counting values, integer values. 1, 2, 3, 4, etc. That's what goes on the x-axis. In earlier chapters, the frequency would have gone here on the vertical axis. Now the probability is going to go on the vertical axis. Let me erase that. So this is a family with 3 children, and you must find the probabilities for the number of girls in the family. Let's skip to B. I want you to give a symbol and a value for this problem for the following. What is the random variable? The random variable in discrete probability distributions is the variable that you're measuring. It doesn't have to do with a random sampling. It's random in the sense that it can happen by chance, or at least you can assume it happens by chance when you're working on the particular problem. The random variable here is the number of girls, so I'll just call that G. What are the values? You could have no girls in the family, 1 girl, 2 girls, or all girls. So that's the values it can take on. Remember, it's discrete, so you expect just integer values like that. What are the total number of occurrences? Well, that goes back to here. What are the permutations for family? You've got 2 possibilities, and you have 3 slots. Because you've got 3 families, that's 2 to the 3rd, there's going to be 8. If you remember that from chapter 4. But now just write them down. You'll need to know them. And it works if you just do something systematic. Say all girls. And put 1 boy at the end. Switch places here. And then a girl and 2 boys. Okay, that gives you 4 of them. Put boys first and do the same thing. All boys. Have girl second. Or have 2 girls. So there's 8. Total number of occurrences 8. Total number of occurrences. Okay. Then you create these little tables here. Put the value of the random variable, 0, 1, 2, and 3. And now you need to know the probability. Well, if there's 8 chances, what's the probability of having no girls? There's only 1 case. That's when you have all boys. So there's 1 out of 8 chances of having no girls in the family. Okay, you can go over here and do 3 easily. What's the chance of having 3 girls? There's only 1 time that you have 3 girls. That's when you have girl-girl-girl combination. That's 1 out of 8. These are also going to be out of 8, but you have to count up how many there are. To have 1 girl in the family, you have this one, here, 3 out of 8, and then the remaining 2 girl combinations. There's a 2 girl combination here, and here, 3 out of 8. Now notice this is a probability distribution, so expect all the probabilities to add up to 1, and they do. 1/8 plus 3/8 plus 3/8 plus 1/8 is 8 over 8, which is 1. Also, none of the probabilities are greater than 1 or less than 0, so that's what you expect. And now the idea is to graph this so you can see what these probability distributions will look like. So here's the graph. As you can see, it has this dplot trial version because I haven't got the license fixed up yet, so I'm still using the trial version. My original license ran out, so sometime in the future all the plots won't say dplot trial version. Alright, so here's just this piece of graph paper, but you don't need all this because you're not going to have 4 girls in a three-child family. So this is the values of the variable go here on the x-axis. This is the number of girls. All right, and here is the probability distribution. Oops, ran out of space. All right, 1/8, 2/8, 3/8. That's the vertical scale you have to add because that's what this particular one looks like. Okay, what is the probability? Let me see if we can find a line here. Just a second. Okay, I think I have the line tool. Now, 0, the probability was 1/8, so the 1/8 goes there. It was 3/8 was the probability for having 1 girl in the family, so this line goes up to 3/8. 2 girls in the family was also probability was 3/8, and now the probability to have 3 girls in the family looks like that. That is your discrete probability distributions. It's a series, or rather sequence of vertical lines. The height of each line is the probability, and you have to figure that out and put that over here on the scale. What's on the x-axis are the values of the variable. This is a game show problem. You'll have a similar one in the test, and there's also going to be one like this on the exam. All right, so the game show, you can choose between 2 doors. Should have said 3. Okay, 3 doors. There's $1,000 behind one of the doors, 500 behind the other door, and if you pick the wrong door, you get a fine of $250. Or you can just get $500 and not even play at all. So the question is, which is the deal? Should you play the game or not play the game? And this is where the term expected value comes in. If you play the game, what is the expected value that you're going to get? And that is really the mean of this probability distribution. So I'm going to write another table again. The variable is the amount of money I'm going to win, or we'll just say A for the amount. Right. And there are 3 ways to earn this money. So the total number of occurrences is 3. And each one is equally probable, right? So it's 1/3 are going to be each probability. So here's my value. Here's the probability. We'll go here just like in that other table. So you could get $1,000, $500, or a fine of minus $250. This is not part of the game. The $500 isn't part of the game. What's the probability when you pick the doors that you'll get $1,000? A third. Because it's 1 out of 3 doors, 1 out of 3 doors, 1 out of 3 doors. All right. If you graph this, I'll just graph it here for you a little bit. Might be $1,000 here. Here's your 500, and over here would be minus 250. And this is A, the amount you're going to win. Your probabilities are going to go here, and each one of them is a third. This is a uniform probability distribution, and so 1/3 is the value here on the y-axis. It's possible to have something negative. In this case, you got fined, it's going to be negative. Now, what is the expected value? That's really the mean, and you compute it like this. So here's your expected value. You take each value and you multiply it by its probability. 10 times a third plus 500 times a third minus 250 times a third. And you work that out. So that gives you 1250 over 3. And you can divide that out and find it's like $417, I think, for this game. All right, this means if you play this game, you can expect to win $417. Do you really going to get $417? No. This just gives you an idea of the game. So if you offered $500 and the expected value of playing this game is $417, it looks like the $500 in this case would be a pretty good thing to take, unless you just wanted to play the game.